Hi guys, in this video we're going to work on determinant of a square matrix. So please open your book to page 535. So there is a simple test that determines if a 2 by 2 matrix has an inverse. So we have to check that AD minus BC. That's what we call the determinant. Okay, so let's say you're given a given matrix has a name A, then it would be determinant of A. Determinant of B. So now, let's say my A would be this. A, B, C, D. Okay? That it will be determinant of A. So AD minus BC, if this one has a 0, then we don't have any inverse matrix exist. So, you can check it on that. If this becomes 0, then no matrix. If this one is not 0, then it will have inverse matrix exist. So yes, that's what you need to check it first. Now what? We can find out the specific inverse matrix, which is 1 over determinant of A. And then you have to switch around this diagonal AD, which is a D and A. And this diagonal, we're having negative signs, which is the opposite sign. Negative B and negative C. That's what we do. Alright, so there is more vocabularies under page 535, which is a minor and cofactors. So these are used when we find out the determinant of a higher matrix, which is 3 by 3 or 4 by 4. But in this lesson we're going to work just only to find out the 2 by 2 matrix. 3 by 3 matrix, we just practice how to find the determinant only. But it's too complicated to find the actual inverse matrix of 3 by 3. So when we go on to the section 7.3, it's gonna be easier to find out the 3 by 3 inverse matrix. So maybe I can explain the section that when we go into there. So for now, we're going to practice with the 2 by 2 matrix, and then we have opportunity to work on the determinant of 3 by 3 matrix. Okay, so page 536, that is introduced us to how to find determinant of a square matrix. As you guys see that it's only workable when we have a square matrix. What is a square matrix? That's a 2 by 2, 3 by 3, 4 by 4. Like they have the same number of rows and columns. Okay, so just this is how they introduce us to find the 3 by 3 matrix, which is a determinant only, but that looks really complicated, right? So I'm going to introduce you the easier way you guys can follow. So, I may use this method when I work with the example 8. So please go on to the page 537 to work on the example 8 together. All right, example 8. So determine whether the matrix has an inverse. And then if they have if it exists, then you can find that out. So your A is this: 3, 1, 4, 2. First, what should I check? The determinant. So determinant of A is 3 times 2 minus 1 times 4. And that would become 6 minus 4, which is 2. Oh, this is not 0, so we can find out the inverse matrix. Now, how can we find it? My inverse matrix is going to be 1 over determinant of A. And this first diagonal, switch the number around. The second diagonal, you're going to make it into the opposite sign. Okay? So now what? 1 over 2 times 2, negative 1, negative 4, 3. So now you should simplify. That would be 2 over 2, negative 1 over 2, negative 4 over 2, 3 over 2. As our book did, you can change that into the decimals, which is 1, negative 0.5, negative 2, 1.5. That is the answer for 2 by 2 matrix. It's not that hard, right? So now 3 by 3 matrix is a little bit complicated, so I need you guys to pay attention. B, I have 1, 2, negative 1, 2, negative 1, 3, negative 1, 0, 1. That's what we have. So can you guys look at the page 536 quickly? That all the way in the middle part, they have a 3 by 3 matrix, and then you can see that the big line that we call the sign of the determinant, which is absolute value of A. So this absolute sign, they have a A11, A121, A12, A13, so they have a 9 elements in there. So first line, second line, and third equal signs. Did you see that the expressions like negative A21, A12, A33 minus A13, A31. So those expression is give us the how we can find the determinant. But it looks really confusing, isn't it? So A13, A31. Yes, if you are having a chance to work on the higher order matrix like 4 by 4, yeah, that way you should know it. But when you just work with the 3 by 3, you don't have to know this, because as long as you know how to find out the 3 by 3 matrix, you'll be good. And then we have a tool, which is a graphing calculator. You guys are allowed to use a graphing calculator in here, so I don't really worry about that. Okay, so those expressions are really, really confusing. I'm going to show you as a diagram so that you guys may remember, easily. Okay, so this step is what we are looking for, those ones. So now, let me use this given question now. All right, so you have to pay attention in all the diagonals. Okay, so this diagonals, starting top to the bottom, those diagonals, I'm using the red. That means plus. We are going to add. So my first number is 1, negative 1, and 1. You guys are always multiply those 3 numbers. Now the second one. So this one is actually exactly same as this. A22, A11, A33, because A11 here, A22 here, A33 here, right? And then my next one is what? 2 and 3. I'm going to make another diagram. So I need 3 elements, but I have only 2. So my diagram, my line, continuously goes to here. So when I look at these, that's gonna be a 1, 2. I have to find an A12, A23, and A31. So those are exactly same as what we have here. But they're having the double negatives in here, so you end up having plus. So 2 times, 3 times, negative 1. That's what I have. Now what? My last line. Starting from my negative 1, I am going to go through those 2 numbers. So that would be exactly same as those situations. Okay? So I have negative 1 times 0 times 2. That's my first part. Now my second part, I'm going to erase all of that. Now I'm going to use a different color. That's the other diagonal, starting from the top right goes to the bottom left. Okay, and then one thing you have to remember is we always subtract all the values. So I recommend you to do this. So the first part you just write down as in order. Now second part, starting with the minus, put everything into the one parentheses and you just calculate it. Okay, So now, my first diagonal is -1 and -1 and -1. You just write down right here. -1 times -1 times -1. Now what? Plus. Because I already take minus out. You just, add. Now my second diagonal is 2 and 2 and 1. Okay? So I go down. 2 and 2 and 1. That's my next. Now what? You go starting from here, 1, and then go through this. 1 times 0 times 3. 1 times 0 times 3. Now what? You need to calculate it. So calculate everything that you have -1 for the first part. -6. And then any number times 0 is what? Just 0. Minus everything together. -1 plus 4 plus 0. So when you get familiar with that, you don't even have to write down all of that. You can just really do it in, quickly. Now, -1 minus 6 become -7 minus +3. That become what? -10. That's how we find the determinant by using our hand. Now, I can show you how to find out determinant of B. And then we can actually find out the inverse matrix by using our graphing calculator. So please, take out yours. Alright, so in my calculator, I have a matrix tab all the way bottom. So I need to tap the second and matrix, and I can load my matrix. So now I chose my number 1 as, the given question B. So I go to edit and click my first one, so that I already put all the numbers there. So 1 to -1, you see that, right? 2, -1, 3, -1, 0, 1. So you manually input all the elements into the matrix form so that you can find that out, your determinant, and then the inverse matrix. Now I go to the my main calculator, and then I want to find the determinant, so I'm going to click matrix one more time, check with the math part, determinant right here. I can find it. Now, what is the name of the matrix which I set it up? That was A. So you have to type A here and close it. And I can get my determinant of A, which is -10. Exactly same as what I just got, right? And I want you to get the inverse matrix. So what you need to do is you're going to use the inverse symbol. So you can click one more time, second and matrix, so that you can type the name of it. And inverse matrix, if you entered it, then you can see all your answers. Compare with your answer on your book. Exactly matching, right? So that's how we find the inverse matrix of 3x3, and then we can find the determinant. As I mentioned, when we go on to the section 7.3, I can teach you how to find the inverse matrix of 3x3 in an easier way. All right? So we go back to our whiteboard, and then I want you guys work on the page 541. So I'm going to give you a question. You can pause this video to work on that question. So I'm going to give you page 541, number 35 and 41. Okay, so I want you guys solve those two questions by yourself, and then we can check it together. So number 41, I don't want you to get inverse matrix. I just want you to get a determinant. That's it. So please don't use your graphing calculator. Just calculate by your hand. All right. Okay. So number 35. We have 2, 3, 2, 2. Alright, so what do I need to do first? Check determinant. So determinant of, let's label as A. Determinant of A. 2 times 2 minus 3 times 2. That is -2, so I don't have any. I will find my determinant inverse matrix of A. Now what? inverse matrix of A would be 1 over determinant, which is -2. My first diagonal right here, what should I do? Switch up the numbers. You know, they are same number. You don't have to worry about it. Now what? Those diagonal, 3 and 2, the opposite sign. Alright? Now, what do I do after? Calculate. So I have 2 over -2, -3 over -2, -2 over 2, 2 over -2. Simplify, that would be -1, and then 1.5, +1, and -1. Alright, that's my answer. Alright, now number 41. We have 2, 1, 1, -1, 0, 2, 1, 3, -1. So please use the form that which I introduced you first, right? We always starting from the top to the right. That will be positive. So now 2 times 0 times -1 plus 1 and 2. Now I go to that. 1 times 2 times 1 plus, starting from 1 goes to those 2. 1 times 3 times -1. Now what? Minus. Everything minus, I told you, right? And then starting from top and go down to the left. 1 times 0 times 1. Now what? 1 times -1 times -1. 1 times -1 times -1. My next 2 times 3 times 2. Close it. Now what? Simplify. So any number times 0 would be 0 plus 2 minus 3. And then now minus 0 plus 1 plus 3 times 3, 9 times 2, 18. Let me double check it. 3, 2, 0, -1. And then 1, 2, 1, 1, 3, -1, okay? And then minus 1, 0, 1, 1, -1, and -1, and 2, 3, 2, okay? I made a mistake right here, 2, 3, 2. I put the 3, 2, 3 by accident. That's why. Okay, so I got a 2, 3, 2. So 4 times 3 would be 12. Now what? 12. Now it looks good. Now I got -1 minus 13, which is -14. Okay? Do you want me to check it with my calculator? I can do it. So you can open your calculator, and I can put the second and matrix. I can go to my B. This would be my new matrix now. Okay? So now you can go to edit B. This is nothing, so I'm going to put all the values. So my first one, you need to put the 2. So clear, you put the 2, enter. So you can just input all the values. Now clear, it will be 1. Clear, it will be 1. Now it's going to the second row and first column. It is -1, enter. 0, stay. And my next is 2, input. Now 1, clear, and clear 3, and clear -1. Okay? That's what I got. So 2, 1, 1, -1, 0, 2, 1, 3, -1. Alright, now I can go back. Now I want you to find my inverse matrix of B because I already input B there. Oh, that's gonna be my inverse matrix. Okay, it's really long. But you know what? I originally want to get it. That was a determinant. Yes. So, second tab matrix. I want you to get my determinant of what? B. Name B. Close it. That would be -14. See? So when you see that's exactly matching. So, you know, when we find out the inverse matrix B, look how complicated numbers are. Oh my goodness. So, you know, we are going to have a chance to practice how to get an inverse matrix of 3 by 3 when we learn section 7.3. All right. So I want you guys go back to the page 537 quickly. We're going to talk about, you know, briefly about the 5 of the important properties of a matrix. So, you know, that will be first one, commutative property, second one, associative property, third one, identity property, fourth one, inverse properties, and fifth one, distributive property. As you guys remember, we learned about that in real numbers, right? But number 1, commutative property is only workable with addition. Multiplication, we learned it already. It doesn't work every single time, right? So does not hold in general. And everything else, number 2, that work. Number 3, that works. Number 4, inverse properties. Inverse properties, yes, it worked. But it's only workable with the, you know, and by when, and we just mentioned the inverse properties that it exists when we have in the determinant is not same as 0, right? And number 5, you can check it, the both of it, multiplication over addition, multiplication over subtraction. It is going to be working. Okay? Alright, so I'm not going to do the application. So we go to the section 7.3 in the next video. I hope this video helps you, and then let's see in the next video. Bye.